Hi, I'm just making this video in response to a Reddit user on the A-level physics subreddit who asked this question, but it could be useful for everyone. So I'll make this video available to anyone who wants to see it. So the user had a specific question about part 2 of this question, which I will get to, but we'll just have to do part 1 first, I think, in order to make sense of part 2. So we've got the volume of an ideal gas in a cylinder is 1.8 times 10 to the negative 3 meters cubed at a pressure of 2.6 times 10 to the 5 pascals and a temperature of 297 Kelvin. And we've got a diagram to show that. Then we've got some important information for later. The thermal energy required to raise the temperature by 1 Kelvin of 1 mole of the gas at constant volume is 12.5 joules. Okay, so that's giving us an amount of energy per mole. That's going to be important. The gas is heated at a constant volume such that the internal energy of the gas increases by 95 joules. Okay, and then it says calculate the amount of gas in moles in the cylinder. Okay, so for part 1, this is a PV equals nRT equation, where n, little n, represents the number of moles. We can obviously rearrange that to make n the subject. If you substituted in the numbers that we've been given, we've got the pressure up there, we've got the volume in meters cubed, we've got R is the molar gas constant of 8.31. And we also have the, I'll shift that up a little bit. We also have the temperature in Kelvin of 297 Kelvin. So if we substituted all of that in, we would get N is 0.19 moles. Okay, that's a good start. So now let's look at question 2, which is the part that the Reddit user was asking about. So it asks us for the rise in the temperature of the gas when we have supplied it with 95 joules of energy. And the person on Reddit was asking, why did we not use Q equals mc delta T, which is an equation that most of you will be familiar with from the thermodynamics topic, where m is the mass of the sample that you are dealing with. So to the Reddit user, whose name I'm not using for anonymity reasons, but you know who you are, the reason we don't use this equation is we don't know the mass of the gas. The question hasn't told us the mass. It has told us the volume, the pressure, the temperature initially, but it hasn't told us the mass. So we can't use that. However, the question has effectively told us the energy per mole needed to raise the temperature, 1 Kelvin. So 12.5 is the energy needed to raise the temperature of 1 mole by 1 Kelvin. So in a sense, we are kind of inventing a new equation that's just applicable to this question. So we're not going to use that. And instead, we are going to say that we've put in 95, and that is the energy that has been used to raise the temperature of 0.19 moles. That was the number of moles that we worked out in part 1, times that number 12.5, which is the energy needed to raise the temperature of 1 mole, times delta T. So that is your effectively Q equals NC delta T but where C has a different definition here, which is energy needed to raise the temperature of 1 mole by 1 Kelvin, which would have units of joules per moles per Kelvin, not joules per kilogram per Kelvin, which is what you would have been used to in the usual equation. So at this point, you can rearrange this and find delta T to be 40 Kelvin. So the crux of the issue is, for the Reddit user that was asking, we were not told the mass, so we can't use Q equals mc delta T. We have to use this slightly different equation that we've sort of invented on the spot to take advantage of the fact that we know the number of moles. I hope that that's useful. Thanks.